There we go. Sorry, I didn't do a check. I'd usually do my check at the beginning that I have the sound turned on. This time I didn't, so let me just start over. There we go. Sorry, I didn't do a check. There we go. All right, so now I've checked I've actually got sound going. All right, sorry about that. A little bit of a false start. So I have just grabbed these questions. I haven't worked through them already. So if I make mistakes while I go, just pop something into the chat if you spot that I need to fix something. Right, so this one here is using de Moivre's theorem. We know that because we have z to the power of something equals something else. Or if you can rearrange it into that format, then you can use de Moivre's theorem. All right, so the first thing we need to do is change the what we've got here into being in polar form, because de Moivre's only works in polar form. So do that by picturing what we have on the Argand diagram. So we've got minus 4k squared in the I direction. So we're actually going to be sitting down here at minus 4k squared on I. Which means that if we turn that into polar form, we have a length of 4k squared and an angle of negative pi by 2, because we're going to go this angle just here. That gives us the argument. Now we can get the first solution. So we'll have 4 solutions with this one. Get the first solution by doing the 4th root. Oh, missed the squared. So the 4th root of 4k squared for the modulus, and the argument gets divided by 4. And that will give us our first solution. Okay, so if we do the 4th root of 4, think about it as square root and then square root again, or you can pop it into your calculator if you're not super confident with that, especially if you've got your calculator set up to be able to do surds. So the 4th root of 4 is actually the same as square root of 2, because if we square root 4 we get 2, so then square root again to do the 4th root. And the 4th root of k squared, well, if we square root k, k squared will get k, so it will also be the square root of k. So in this case we have the square root of 2k is our modulus. Now the argument is minus pi by 2 divided by 4, so that is going to be minus pi by 8. Now we will have 3 more solutions that's possible. And there's a couple of ways to think about this. It's either by adding circles on at the beginning and then doing the same process of dividing by 4, or we know that there's 4 roots and they are symmetrical around the Argand diagram, so we can just go ahead and add on a quarter of a full circle. So that would be pi by 2. That's the option I'm going to take on this one. I just find that a little bit more straightforward, especially when we're just adding quarters of a circle. So the second route will be to do the square root of k cis. Now if I start at, let me just take my calculator over here. If we start at negative 1/8 and we add a quarter of that circle, well, a full circle is 2 pi, so half the circle is pi, and a quarter of the circle will be pi by 2, or a half. So this will be 3 pi by 8. Now if I pop this onto the Argand diagram to show you how I'm thinking about this, this might make it a little easier to see. Let me just come back here. The first solution was over here at, I mean, that angle's not great. So this one here would be minus pi by 8. The next solution would be to add a quarter of a circle to that. So that's where we get the 3 pi by 8. The next solution around would be to add another quarter to that one. So now our third solution, let's just come back here. So Z3 Again, the modulus hasn't changed, so we're still on the square root of 2k, but the angle has changed. And when we're at 3 pi by 8, so the second solution, we're going to add another quarter of a circle, which is half of a pi, which brings us to 7 pi by 8. And then the fourth root of this, the last solution that we have, and just be careful to make sure your z's look like z's and not 2's, is to do another one of those. So let me just pick out a colour here, and it would be over here. Now we don't want to go this way round because we'll end up with an argument that's gone over the pi line like this. So if once we're into that third quadrant there, we'd rather go this way round. So we'll start at minus pi by 8, so minus 1/8 of pi, and this time we're going to take off half a pi, which is a quarter of a circle. So that is now root 2k cis of minus 5 pi by 8. And I'm just going to double check that I haven't made any mistakes. Yep, that's looking good. All right, so getting achieved from this section is just this bit here. I think you might need to simplify it, so possibly getting to this bit here, but probably just this bit here. So that would be your achieved line right here, and then all the way through finding the other 3 solutions would get you the merit. Okay, no questions just at the moment, so I will carry on. Just 1 minute, let me get to the right place. Okay. So now we are on differentiation. Oh, this is a nice question. Okay, so find the x value at which the tangent to this function is parallel to the x-axis. So we're going to differentiate, and with it being parallel to the x-axis, that means we've got a flat line, so the gradient will be equal to 0. So first thing I'm going to do is take my y and write it in a linear form. So we have it like this. It would have gone, that e that's on the bottom is done to the power of minus 1 because it was on the bottom, plus 8x. So this becomes 4. Now, if we do powers of powers, then we're going to multiply out those powers. So it'll be minus 2x plus 2, like so. And in fact, we don't need the bracket now that we've times that power out. So it will look like this. And then dy by dx will be to differentiate each term. So if we differentiate e, we get the same power. The 4 doesn't change anything, but we will multiply by the derivative that is inside of that e function. So that will be timesing by minus 2, because that's the derivative of this function inside of e. We're doing a little bit of chain rule. If we differentiate 8x, we get 8. So this is now minus 8 e to the minus 2x plus 2 plus 8. Okay, now if that's parallel to the x-axis, we will set that to be equal to 0. Now this will be that 8e to the minus 2x plus 2 is equal to 8. So e to the minus 2x plus 2 is equal to 1. minus 2x plus 2 is equal to natural log of 1, because natural log is how we undo e functions. And then natural log of 1 is 0. And if you're not sure of those ones, you can just pop it in the calculator to check. So we then have that 2x is equal to 2, so x is equal to 1. Okay, achieved on this one was if you could get a correct expression for dy by dx. So that's this line just here. And then finish it off for a merit. Okay, now last one, integration. Okay, so a tank holds 2,500 litres of water. The tank develops a small hole in its base. Water leaks out at a rate that's proportional to the square root of the volume of water remaining in the tank at any instance. So I'm going to pause there and write that bit down. So I know I'm going to need that equation. So the rate at which the volume of water is changing, we can write that as dv by dt. So how much v is changing with respect to t time. Now we're told it's proportional to something, so it'll be equal to k times that something that it's proportional to. And what it's proportional to is the square root of the volume of water remaining. So that is the square root of v. Or in other words, kv to the half. Now we're going to use solving differential equations to work out the pieces of this so that we can then go ahead and work out after 2 days the leak started. 2 days after the leak had started, there was 475 litres that had leaked out of the tank. We'll use that to then go on and solve how long would it take to get to empty. Okay, so that's the process we're going to go through. This means I need to integrate and get a function of v equals something. So that's the aim. And then I could work out when v is equal to 0. So we've got to separate variables. We've got v and t mixed up. So we want the v on the left-hand side to match with where dv is. So where it was v to the half, it's now going to be 1 over v to the half, or v to the minus half. In fact, I won't skip that step. Let's go 1 over v to the half dv is equal to k dt. So what I've done there is bring the dt up and multiplied it, take the v over and divide it. Okay, let's just get that out of the way. And then we will integrate both sides. Now with v to the power 1 over v to the half, that to me is easier to think of it in powers of being v to the minus half, so that I can, let's just tidy that up, so that I can think about integrating that. So to integrate, we are going to increase the power by 1. So minus a half up 1 is going to be a half. Then we divide by the new power. So dividing by a half means we have 2. And k integrated with respect to t is just kt, and then plus c. Okay, now we substitute in some values to work out the k and the c. So when t equals 0, we've got the volume is 2,500. So 2 times the square root of 2,500, just substituting in for v, happens when we have k times 0 and then plus c. So c is equal to 2 times the square root of 2,500. So c is 100. Okay, now just to try and keep this all on one screen, I'm going to come up to this section here. So now we know that 2 times the square root of v is equal to kt plus 100. That's from, let me just show you, it's this line here that I've turned into this line here. by putting in the value of C. Right, now we can use the other information. So 2 days after the leak started, we had lost 475 litres. Okay, so 475 off of 2,500 means the volume is 2,025. So 2 times the 2,020 square root of 2,025 will be equal to K times 2 for the 2 days after plus 100. So now if I square root the 2025 times that by 2, we can take off the 100 and divide it by 2, and we get K equals minus 5. All right, so now, almost there. We've got the formula is now minus 5t plus 100. We want to know how long it will take for the tank to be empty. So we want to set, hold up. Here we go. We want to set the volume to be equal to 0 and work out what does t have to be for that to be true. So 2 times the square root of 0 obviously is 0. 0 plus 100 is equal to minus 5t. Oh, sorry, not plus, minus 100. Minus 100 divided by minus 5 is 20. So it will take 20 days. Okay, all done. And this one, I'm not sure how long we've been going. Kind of lost track of time. Where are we up to? So it's been, I think, about 15 minutes since I actually started working on them. Again, 3 merit questions done in around about 15 minutes. And when you're approaching this to do all 3 papers in 3 hours, that's absolutely plenty of time for you to be getting a merit and then be trying for that excellence as well. All right, thank you for watching. We'll leave it there, and I will let you know when I will be doing the next live, going through another 3 questions and showing you how to easily work towards that merit.